Look up right now. Tonight. Whatever you see up there, you're not actually looking at space. You're looking at time. Every point of light left its source at a different moment, some 8 minutes ago, some before Earth even existed. You're not looking at one sky. You're looking at millions of different pasts, stacked on top of each other, arriving at your eyes at the exact same second, and here's the part nobody tells you, the farther out you look, the less any of it makes sense. Scientists pointed the most powerful telescope ever built into deep space, and what came back wasn't just distant. It was wrong. So today, we're going the way the light travels, starting close to home, going farther, and farther, until the universe stops making sense. Space is the one thing every single human has looked up at. Yet the deeper we're able to see, the weirder it gets. Not scarier because of monsters. Scarier because of what we can't explain. Even the idea that space is empty and silent is something we invented to make it feel manageable. There's no biological instinct that prepares you for how big this actually is. So what does it actually look like the farther out you go? Past the moon. Past the planets. Past our galaxy entirely. Turns out, the answer is way stranger than, it's just more stars. Let's start small, with the part of space we've actually touched. The second you leave Earth's magnetic field, you leave its protection too. Our planet has an invisible shield deflecting most of what the sun throws at us. Step outside that shield, and you're exposed to galactic cosmic radiation, heavy particles flung from somewhere deep in the galaxy. You can't just build a thicker wall to stop them. A thicker shield actually makes it worse. The particles slam into it and create a shower of secondary radiation on the other side. When those particles pass through a human brain, they tear apart DNA strands and damage neural connections. An astronaut on a multi-year mission to Mars isn't just risking radiation sickness. They're risking landing on another planet with a measurably different brain than the one they left with. We haven't even left the solar system yet, and space is already trying to rewrite your neurons. But that's the safe part. Let's go farther. Every time you look up, you assume you're seeing now. You're not. Light from the moon takes about a second to reach you. Light from the sun takes 8 minutes. That faint star you can barely see, its light could have left before you were born. It might not even exist anymore. You'd have no way of knowing. Now stretch that further. The oldest light in the universe, the leftover glow from right after the Big Bang, has been traveling for over 13 billion years to reach a camera lens on Earth. In that ancient light, there are tiny variations in temperature, differences smaller than 1 part in 100,000. Those flickers are the reason anything exists. Every galaxy, every star, every person who has ever lived grew out of those almost invisible ripples. So when you look up, you're looking at the leftover echo of the moment everything started, and it never actually stopped happening. It's still arriving. Right now. Not everything in space announces itself with light. Black holes, by definition, don't emit any. Most black holes we know about, we only know about because of what's around them, the glowing disk of matter spiraling in. But some black holes have no galaxy around them at all. No disk. No warning. These are called rogue black holes, untethered, drifting through space alone. One was identified using Hubble, moving at roughly 3 million miles per hour, with nothing anchoring it to a star or galaxy. It's billions of light years away. That part's comforting. Here's the part that isn't. One with no light and no disk could be much closer, and we'd have almost no way of detecting it. Not until its gravity started doing something to objects nearby that we could actually observe. Zoom out past our galaxy now. There's a region in deep space, about 250 million light-years away, that astronomers named the Great Attractor. It's a gravitational anomaly, a pull so strong it's tugging our entire galaxy, along with tens of thousands of others, toward it. The strange part isn't that it's pulling us, gravity does that. The strange part is we can't clearly see what's causing it. Our own galaxy's disk blocks a direct view. We're moving towards something we can't fully see, pulled by a force we can't fully explain, at a speed we didn't choose. One specific star, because this one genuinely stumped astronomers for years. Astronomers call it Tabby's star. Every so often, it dims, dramatically and unpredictably. Not the small, regular dip you'd expect from a planet passing in front of it. Astronomers ruled out the obvious explanations one by one: comet swarms, dust from a shredded planet. Because nothing fit cleanly, even the idea of a giant artificial structure got serious discussion. The leading explanations are still natural ones. But the fact that this was ever seriously discussed by actual scientists should tell you something about how strange this star's behavior really is. Here's where it gets genuinely unsettling for the people who study this for a living. When the most powerful space telescope ever built was pointed at the farthest parts of the universe, astronomers expected small, faint, messy young galaxies. Instead, they found galaxies that were bright, massive, and strangely mature, existing just a few 100 million years after the Big Bang. Far more than any model predicted. One researcher, staring at the data, said the field had a problem, because these galaxies weren't in the storybook. One of these galaxies, discovered in 2025 and nicknamed the Big Wheel, has a fully formed spiral structure, despite existing within the universe's first 2 billion years. And another one of these impossibly early galaxies doesn't rotate at all. No spin. None. Non-rotating galaxies are something you'd expect only in very old, evolved systems, not something that formed less than 2 billion years after the universe began. So the farther out, meaning the farther back in time, these telescopes look, the more they find objects too developed to exist yet. Nobody's saying the Big Bang didn't happen. But some of what we're finding right at the edge of what we can observe doesn't match the timeline we thought we understood. Here's the part most people never hear about, because it doesn't make for a flashy headline on its own. There's a long-standing disagreement in cosmology. Different methods of measuring how fast the universe is expanding keep giving different answers. Some researchers now think this measurement gap might be connected to the same unexplained early galaxies we just talked about. In other words, the strange things we're finding when we look far enough might not be isolated oddities. They might be small cracks pointing at the same much bigger problem. We're not talking about aliens. We're not talking about ghosts. We're talking about real scientists, using real data, quietly saying, the further we look, the less our own math adds up. Here's the last piece, and it ties everything together. Researchers studying how people react to space photos found something interesting. Unlike a normal starry night, deep space images, nebulae, galaxy clusters, can trigger genuine discomfort in viewers. Not just awe. Unease. The proposed reason is simple. Humans evolved looking at a night sky we could recognize. We did not evolve looking at raw deep space. So that unease you feel scrolling through real deep field images isn't just in your head being dramatic. It's a documented reaction to something your brain was never built to look at. So, why does space get creepier the farther you look? Because the farther you look, the further back in time you're seeing. Closer to home, it's radiation and invisible black holes. Farther out, it's unexplained gravity and flickering stars. All the way at the edge, entire galaxies that shouldn't be finished yet. You're not just looking at the sky. You're looking at the limits of what we actually understand. And somewhere past that limit, we genuinely don't know what's out there yet. If this kind of thing messes with your head a little, hit subscribe. I put a new one of these out regularly, and trust me, the next one goes even deeper.